Bienvenue, welcome to Ippon, and welcome to our meetup. I will present, so the first time I'm host meetup at Ippon. I'm CTO of Ippon Lille, Strasbourg and Luxembourg. And just one rule during the meetup, it's a little bit funny rule, but no recruitment. My strategy for the meetup is to have this environment of sharing, of partage de connaissances, partage notre expérience, and not to hire you or hire anyone else. I'm not a French guy, so that's why I have a little accent. And I really appreciate doing the networking just to share our experience. So today we will speak about the data. We choose the two different topics for this meetup, basically because, you know, the AI hype is everywhere. The data we were doing a lot of time, a long time ago. But now with GenAI, it's like a trend. A lot of guys currently they share the basics like the POCs. They do the proof of concept without the industrialization. My goal and our goal is to share the real life examples. That's something that is already in production, to share this experience and not to speaking about the fancy AI stuff. So welcome one more time. And the first speaker, it's Nail, who will present the talk evaluation of RAG-based application. And please, welcome.
Hello everyone, my name is Nail. Today we are going to talk about the evaluation of RAG applications. I'm a machine learning engineer at Adeo, and sometimes I'm tech lead, sometimes I'm a machine learning engineer, it depends on the use case. In case you, for some reason, you don't know what the Adeo company is, but I hope you know, but in fact it's the French holding company. The most well-known brand is the Leroy Merlin, and we are presented in 21 countries, quite a huge company. Before I worked in Russia in that company, so now I'm working in France. Today's agenda is we're going to talk about the RAG itself, what it is, in case you don't know, how do we evaluate RAG, common metrics, the ways to evaluate, what kind of frameworks we can use for it, and some Adeo's insights, how do we use RAG, how do we evaluate RAG, some takeaways. So the first question, do you know what RAG is? Like, can you, like, at least, okay. So you know what is RAG, and maybe you also try to create a POC with RAG, or maybe even put something on production. Okay, several guys. So for those who don't know what is RAG, I will start with some entry-level slides, like just to explain why we use RAG, where it's useful, where it's not, etc., etc. When it happens to talking about the amount of data, usually we operate with like the size of the Wikipedia. It's like around 5 billion of words. It's like quite huge amount of words. It's like our entire knowledge of the world. When it comes to the LLMs, in fact, it's like 3,000 times bigger than the knowledge of the Wikipedia. It means that LLMs, they learned a lot. But the problem with the LLMs is that they didn't learn nothing about your entire documentation of the company, right? So if you will try to ask anything about what's happening in my company, how to do something like how to order a computer for myself, it won't be able to answer because it just didn't read anything from your internal knowledge. And usually it happens like if you have some questions, you go to your colleagues, your experts, asking the questions. Hopefully they know how to answer you, and hopefully they, from time to time, they put their knowledge inside the documentation. So they take their piece of brain and dump it into the Gitbook, Notion, Confluence, and it simplifies a bit the process. So now you can read documentation, Of course, it takes a lot of time since you need to search for it. And this is the place when the RAG becoming useful. Basically, it's the way to provide to large language models the access to the external knowledge. In this scenario, it's just the internal documentation of your company. Sometimes it could be something even better, cooler. You can see like there is a different types of usage of the RAG. You can have like internal company, as we just discussed. You can talk. You can create the customer support service. Imagine you calling to the call center and you're asking how to return my package because it's not the products are not fitting to me. All that questions that are directly related to the internal knowledge of the company. And basically, when it comes to RAG, it's the huge black box which contains of two main subblocks. The first one is the retrieval part. The retrieval part, it talks to some database. Your task is to take all your documentation you want to use in your RAG and put inside this database. We will not go into details how it works, just because it's not the topic of this today's talk. And the second block is the generator part. So basically, the idea is that you search for relevant context in your database. You take this context, you take the question of the user, and give it to LLM, hoping that LLM will realize that this is the question about these documents and will try to answer your question. So basically, this is how RAG works. The problem is that no, it's not the problem. The cool thing is that to create your first POC, it's like quite easy. If you look at the amount of frameworks that appeared in the last 3 years, like there is like hundreds of different frameworks saying that you can build your own RAG in a few minutes, and you don't even need a data scientist to create your POC. The problem is that when it comes to the production, it becomes way harder. Why? Because you may probably already used ChatGPT, and each time you're asking the same question, it may generate different responses. It just because the LLM is still probabilistic model, it's a bit of black box. There is a lot of situations when it hallucinates. Probably you already heard about the use case when the lawyer tried to use the ChatGPT in the court, and it faked some facts. So it's a bit pity. There is a situation when you can trick any LLM-based application. Like this is the scenario when the guy managed to buy a car for $1, just because it's quite easy to talk to ChatGPT to create a huge context and start to trick it a bit. So this is the part. When it comes to that, it's very important to have evaluation of the RAG. So before putting something in production, you should be sure that you won't have that kind of situations that we just saw. Of course, you can start to read all the responses it gives. You can try yourself, imagine different questions. You can pose it to the RAG. You can check how it answers, but it won't scale. Like you can do it once, maybe, but it won't be like reliable. It won't be scalable. And the cool thing is that there is certain papers that are saying that you can use another LLM to judge the RAG. Like you using one LLM to judge another LLM, evaluating like is this responses are good or not. And if you want to use another LLM to judge the another LLM, the first step you would have is creating your good data set. And when it comes to data set, there is a lot of open source data sets that you can take from the internet, allowing you to evaluate any RAG. But the problem is that they are not relevant to your certain use case. So it's important to craft. Maybe you already have this data set. Maybe you can craft it manually. Usually it comes that you need to have user question, answer, and relevant documentation where this answer could be inferred from. When you have this data set, you can go to the next step is picking right metrics. There is two types of metrics. The one type of metrics are focusing on the RAG retrieval part. So it's the part just to evaluate how well your RAG is dealing with searching of the relevant documents. And the second part is how well your RAG is generating responses. So we are going to deep in the technology. So it's like fun part is almost finished. Sorry for that. There is 4 main metrics. The first one is the context recall. The context recall measuring how well you retrieve relevant documentation. Like, are you able to retrieve all the relevant information to answer any question? And usually it happens like you have a ground truth from your data set. You ask LLM to split this ground truth into the different statements. And then you're checking if this statement exists in the document that you just retrieved. For example, in that scenario, we have 3 statements, and only 2 of these statements are exist in the documents. It means that we can calculate our context recall, saying that the context recall will be 2 divided by 3. This is the metric we can get for that particular question. So then we can run this metric over all of our questions, and then create an average or a median of the metric. The second one is the context precision. If you work with data science, you can recall that they sound the same as in data science, like you have recall and precision, but it's a bit different. The precision is focusing more on how well you rank your documents. It penalizes you if you, for example, you retrieve like 10 documents that may contain the answer for your question, and if your right documents are very in the bottom, the metric will penalize your system, so you can tune your system to make the metric higher, better, just ranking better the retrieved documents. In that scenario, like, we can see that there is a bit complex computation. If you want, you can see these slides a bit later, but this is just the formula how you can calculate the context precision. Then we have the faithfulness is the third metric, but it only focusing on the generation part. The faithfulness means how much bullshit things your LLM putting in the answer. When I'm saying that, I mean how much statements on the answer is just taken out of nowhere. It's like purely hallucinates. In that scenario, imagine you have your generated response. You have 3 statements in it, and only 2 of the statements are exist in the retrieved documents. So it means that the third one is just taken out of nowhere. In the production scenarios, it's like very important not to have that kind of situations. And the last metric is the answer relevancy. It's as you can understand from the name of the answer relevancy, it means just how relevant your answer to the actual user's question. To measure the relevancy, you split your response in statements again, and then for each of the statement, you're just asking LLM, is this relevant or not, and then you can calculate the overall relevancy of the entire response. Yeah. So now we know how to measure. What do we want to measure? How do we want to evaluate our RAG application? Now it's time to pick the right framework. Of course, you can build your framework, your own framework. You can spend some time build something from the scratch. But maybe as a good first point, you can take an existing framework and start with it. We took the Adeo. We took top 3 most popular frameworks. It's a RAGAS, GSCART, and Ipp'event. From the chart, it's the chart of the stars on the GitHub. You can see that actually they becoming more and more popular just the last year. So it's just the beginning of the hype of the RAGs and the evolution of the RAGs. So people get so that it's very important to evaluate RAGs before putting the application into the production. And I would just propose you to have a look at the evaluation of these RAG frameworks we did. So we just try to assess and pick the best application, the best framework from these 3. We start from RAGAS for the task of the dataset generation. So it happens that usually when you want to create your RAG and evaluate it, you don't have a dataset. But these frameworks, they provide the possibility to generate your own dataset, like synthetic one. So you provide your own documents. you feed this framework with your own documents, and it tries to generate questions and answers based on your documentation. So then you can use it to test your own RAG. In case of RAGAS, it's quite nice framework. It allows you to cover all the basic scenarios. It can allow you to generate different types of questions. The main problem is that we try to use it in our use case. You can adapt question generation for your particular scenario. You can provide personas. It's like you can say that I'm building the data set for that use case. The person who will be asking the question is, for instance, the customer of the store. You try to adapt the question that generated for that persona. You can provide some different personas like professional customer, amateur customer, etc., etc. The problem is that I try to generate like 200 of different samples from of the data set, and only 56 of them was relevant. So all the other was a bit not that good in terms of quality. When it comes to Giscard, it's quite nice framework. The only missing point is that it's very, very slow. I tried to guess why it's that slow. I checked the source code of the framework itself. In fact, they are not using the async calls. They are not parallelizing the execution. So you can wait like 15, 30 minutes, and sometimes it could fail after 30 minutes of running. And then you need to rerun. It's very expensive. We decided not to use the Giscard. Even it's providing a lot of different question types. It allows to customize the generation. You can provide your own prompts. The third one is DeepEval. Me personally, I liked this framework mostly. The main power feature of the DeepEval is that you can assess the quality of generated questions by itself. It can ask another LLM to assess each generated sample. In case the sample is not good, it tries to regenerate it. You can also provide some different strategies of regenerating samples. Quite powerful framework, so we ended up with it. So when I provide 200 of when I ask for 200 of the samples, it generated like 120. So it just means that you need to spend less and less time on manually verifying what's happening during the generation. You don't need to regenerate more and more your data set. The second part of using the framework is evaluation, of course.
I have just a question on the slide before.
Yeah.
Isn't it faster to create your own data set manually rather than using this framework that could be biased by the LLM weights?
Yeah, sure. You can create, and we have scenarios on Adeo where when people creating their own. The problem is that when it comes to Adeo, you would need to create that amount of data sets, the amount of business units you have. Let's say currently we're building the RAG for France, then we are going to build it for Italy, Spain, and other countries. And then you need to be an expert of that languages, or you need to ask. Yeah. So when you need to do this once, it works well. When you need to scale it, sometimes it might be tricky. So you can try to optimize it, hoping that it will be okay.
The only thing I'm worried is that because it's generated by LLM, it's by nature biased compared to human reasoning, and the thing you are trying to test is by default from LLM, so it's inception.
Yeah. It's like, but in fact, it takes your documentation. So basically, you're providing your docs. You try to adapt the generation to be unbiased. Like you can provide like in case of RAGAS, you can provide the persona, saying that the persona who's asking the question is like generic customer of Lille. You can say that he's interested in that. You try to unbias it, but you're right that it will be biased. So that's why you will need to have your manual validation to see is this data set is right or not. But I would propose to ask questions a bit later since we can go out of the time. So the evaluation part. The most important one, in fact, there is Ragas. I will go a bit faster on that slides. In case of Ragas, quite nice. It covers all the basic scenarios. It has all these free metrics, even more. It works fast. The only cons is that it does not provide any reporting. You can get the result of evaluation, but there is no explanation of why is that particular metric is looking like this. In case of discard, it works very slow. Like you're also waiting for 30 minutes to compute your evaluations, but at least it provides you a nice charts. Like it generates HTML file, so you can see like summary of your metrics, etc., etc. The funny fact is that the discard, they just decided to take the Ragas metrics and wrapped it, so they don't develop their evaluation by themselves. And the DeepEval, one more time, is the most powerful one. It provides you a lot of different metrics. You can create your own metrics with GEval and the DIG customizations. I won't go into details. I just make you know that there's like tons of different ways to create your own metrics, even more powerful that we just saw before. So in fact, we ended up with the DeepEval for both for dataset generation and RAG evaluation. When it comes to how do we use it in Adeo, we try to build the evaluation pipeline. So it's a pipeline that each time we provide any change on the RAG app, like will it be we play it with different databases for retrieval part. We play it with different strategies of retrieving, searching the documents. In fact, it's very, very nice to be able to see how it affects on your metrics. Because at the beginning, when we just started to build the app, we had a lot of different ideas on how we can improve the retrieval part. For instance, when you receive a question from the customer, you can ask LLM to rephrase this question to generate like 3 more sub-questions. In case a customer provides some very unclear question or maybe too much complex question, so you can ask LLM. So we had the idea to implement this thing. We started to test it, and we realized that you don't need to do that if you're just increasing the size, the amount of documents you retrieve at once. Like instead of spending more 2 seconds on retrieval part when you need to rephrase, we just increase the size of the amount of documents we retrieve. Instead of 3 documents, we start to retrieve 10 documents and battery rank it. So it covered this gap of liking the good retrieve documents. So just a bit more details how it works inside. We have a step that loads dataset from object store. Object store is GCS where we store our pre-generated dataset. So we load it. For each sample of dataset, we retrieve relevant documents. Then we generate responses, and then we can evaluate both parts, retrieval part and the generator part. If you're changing only retrieval part, you can test only retrieval part, just switching off the generator evaluator to not to spend much money on LLM, etc., etc. So in fact, we ended up with the ZenML as the framework to create the pipeline itself. We're using MLflow to log every metric we have. There is one more part I didn't talk to you because we just discussed the way to evaluate RAG application in offline before deployment, but we also have a Datadog where we send all the traces. It's the traces of what's happening inside the RAG, how it goes from the block to block from the step to step, and what it generates in between. It's very interesting to see what's happening inside. You can measure the time it spends for each request. It's not an advertisement of Datadog, but there is also evaluation inside, so you can check in real time, like it can evaluate your each request. Maybe important takeaway when we run the evaluation using this the DeepEval framework. even with the good framework, it happens that each time you run the evaluation, the same data set, it generates a bit biased, a bit different results. So we ended up with running it 3 times in a row, and then taking the average, just being sure that at least 2 or 3 times it's showing us a good result. So we are taking the average. When it comes to how it looks like, we have a beautiful ZML pipeline that is on the left, and we have some dashboards of the ML flow. Like we have different runs. We just try to put some information, what's the run about, what we changed. Did we change the database on something on the database side? Did we change the prompts or something else? And then you can see the given input and the reasoning of the framework, why the score is like, for example, it says that for the first input, the score is 1, and then it tried to explain why it put 1. It's quite nice to have this when you try to debug reason evaluation doesn't work. That's it. So it's time for questions.
So, yes, I present you Ekaterina Rezanovich, who will tell us about the knowledge graph and detection of the outliers.
It's my part of the presentation.
Sorry.
So thank you. Okay. Hi everyone. Imagine you're shopping online and you keep getting product recommendations that don't match your interest or your search queries. Of course, it's frustrating, and this happens because of the hidden errors in the data, errors that knowledge graph outliers detection can solve. So today I will tell you how we're enhancing data with a seamless customer journey. As I said, my name is Ekaterina. I am data analyst in CCDP data team in Adeo. And before I will start my presentation, of course, I want to share with you the experts, the dream team who made this topic possible. Some of them are here today, so thank you that you're here today. Okay, first quick question. Do somebody know what is knowledge graph? Not people who had the pictures on the previous slide. Yes? Shortly, maybe you can share.
No,
you just know. Okay.
No question. I did my part.
So, knowledge graph, it's all about structuring and connecting information. Let's take a step back. Why does this matter, and how does this impact on the real world data? Today, customers, me also, expect seamless, intelligent, and personalized experience. But to achieve this, we need high quality, structured, and enhanced product data, of course. Our knowledge graph outlier detection solution ensures data accuracy, consistency, and reliability by identifying errors in the product data. We are leveraging AI, we automate data validation, enhance product categorization, and improve search and recommendation systems. And as a result, we have better customer experience, faster implementation for the business units of the knowledge graph, and more efficient operations for merchandisers and taxonomists. And what is our vision of this product is capitalizing all the expertise of the DIY we have in the machine-readable form with AI-driven solutions and enhancing with the global knowledge. And at the end, we have good data. That means good customer experience. Quickly, I will explain you what is knowledge graph. If you don't know, it's a knowledge model network of connected concepts, events, situations, relationships, events. Each piece of information has clear description in the knowledge graph, as you can see on this simple example, and helps to explain another entity in the knowledge graph. And we are talking about 3 main points. It's database, it's graph, and it's knowledge base. This is a simple example of what is knowledge graph in DIY world. So this is an example of our CCDP knowledge graph. It's a product and relationships between them. Of course, this work is in progress. So you can see how products potentially can connect with each other. Two main points I want to share about the terms. It's ontology and taxonomy. Ontology is a description of all structure of classes, properties, relationships, everything we have inside the knowledge graph. And taxonomy is a tree to organize a concept in a hierarchy way. And there are infinity of the relationships in the knowledge graph. It can be the broader. It means like belongs to, accessory, made of, for installation, anything. It depends on the number of ontology classes and the types. We have a lot. It's brands, colors, product sets, effects, product series, typologies, etc. So this is an example with the real products from our knowledge graph. So you can see that we have one taxonomy tree, some concepts that belongs to others, some concepts that are used to install another concept. Products belong to different levels of the hierarchy in the knowledge graph. And important thing is population rules. So it's like what population rules in action. It's an option to automatically group the products by the categories in the special concept. So we use models and model attributes to categorize products and avoid manual error in this part. So what is, I know there will be a lot of technical questions about the knowledge graph, so we are starting the technical part. What is the knowledge graph in data tools? We have the website, for example, Leroy Merlin, that retrieve the data about the product during your usage of site from Opus. Opus is search and publication common interface of the GitHub repo. Then we retrieve the taxonomies from the pool party. It's the kingdom of our taxonomists. It's a platform where we store our taxonomies and ontologies. Neo4j, it's a graph database. I will show you after, where we store taxonomies also. A lot of other information like outliers we store in MongoDB, and our favorite Google BigQuery data warehouse, where we export our calculated data. What is graph database? It's a simple example. What is it? It's an example of Neo4j from the internet. You can find others. This is how the graph database looks like. And you can use the Cypher language to query the data, like you use SQL to query the data in Google BigQuery, so we can use Cypher to query the data in Neo4j. Also, it can look like this. It's more common to our Adeo graph base, so there are some products that belongs to some concepts, more common to our Adeo knowledge graph database, and that was my face when I started to work on knowledge graph. Little joke for the atmosphere. Actually, it's spoiler. It's cool and very interesting project. So I will explain you what we did in here. Of course, we need some tabular form of our data to use in ML algorithms, in analysis, in data pipelines. So we have the tabular form of our data in Google BigQuery. Looks simple. Population rules, products, relationships, concept products catalogs. But actually, because knowledge graph, it's a very complicated organism, you need to take into consideration all the entities to, at the end, to have the proper data for your analysis. So it's also not always easy task. But we did and doing several streams on the data part in the knowledge graph. For example, it's population rule suggestions, importance calculation, relationship quality, definition generation, and others. But today I will focus on the outlier detection case. which is in prod. So I divided my speech into 4 parts. It's explain you what is the case, how we create a solution, how we distribute this solution, and how we monitor it. Of course, we need to ask the question, what is outliers and how many of them we have? What models we can use, which one is more efficient? How and in what format we can share our suggestions with the business units, and why, and what we want to monitor. So let's start with the first part. The first part is that we started with a little piece of a knowledge graph, only with one type of the concepts. It's nature of product. It's about 4,000 or 5,000 of concepts. And business estimation is we have from 1 to 5% of outliers in it. What is an outlier? For example, in here you can see the concept penseuse électrique. Sorry for my French pronunciation. And in here we should have only penseuse électrique, but we have some stuff for using the penseuse. For example, the band and other stuff, so like accessories or some products complementary for the penseuse électrique. And for now, it's the current situation. We have 8 business units that are in prod. It's 5 countries with Leroy Merlin, Bricoman France, and Obramat Spain and Portugal. We are going to the models. I will explain you 2 versions of the models our data scientists checked, and explain why we chose one and not another. The input data is designations or definitions of the product we have in our database. It can be also the description and the product name, depending on how much data we have in this designation. And we'll go into embeddings. Neil started to describe this. In the simple word, embeddings it's like mathematical form of the text or images or audio you can use in your ML algorithm to create your ML models. So in this graph you can see an example of products we transform to the embeddings according to the designation, and potentially there are groups according to the description of the products. There is an estimation of 1 to 5% of outliers, and the first approach was to 1 model per concept. So it's like 1 versus others. So each model task is to identify if this product belongs to this special concept. And as a result of the model, it's a probability that this product belongs to this concept. Here you can see we have 1 potential outlier because it belongs to the class 1, because it's a color green, but according to the description of the product and the probability, it should belongs to the class 3. And in here we need to identify the border, the probability threshold, where we want to filter our potential outliers. And of course we want the highest probability that we can use, but of course we need to verify all the outliers on the border of the threshold. And there is interesting approach to do, because our data scientists proposed this implementation with the agile dynamic schema of working on this model, also with LLM validation, of course, at the end. But there are some issues with this model. As you can guess, a lot of models to train, so 1 model per concept. So even for our small case, it's 5,000 models. A lot of time to train. We need to run the models on the whole product catalog, so it's several millions of the products. Identify thresholds for each model. All the concepts are different. Some concepts contain 1,000 of products, some concepts 30 products. So it's very difficult to manage this. So we have our second detection model version. It's simpler than the first one. It's better in obvious outliers, so like we are doing the huge clean of obvious outliers in the knowledge graph, and it's faster. So the idea is the same. And the model idea is term frequency inverse document frequency. So we measure the important words into the specific document. In our case, it's concept. So for all concepts of products, we identify the most important words in this concept. Here is the formula if you want. Let's go to the example. So we have two products. Pensos, and the second one, please read by yourself. There is a product designation, and for the concept Pensos, we identified the most important words. For example, it's Pensos, Grinder, Sander, Ponsage, and others. And according to this, the first product is not an outlier, the second one is an outlier. So, looks nice, looks good. But of course, we have some issues with this model too. It can be the words, the situations when the words are popular, but not popular, but important for this concept. And there are some tricky cases. For example, product designation contains the word with a high probability for this concept, but it's not the main word in this description. For example, the first description, it's Persos. It's okay for the concept Persos. It's Persos, not an outlier. Simple. The second one, it's a battery, pour Persos. So we have the word with high probability. For us, it's an outlier, but the main word in this case is battery. But for the model, sometimes it's difficult to identify these cases, and potentially model results can be both not outliers in this case. But of course, we are missing all the time our good friend LLM in this case we can use to filter out some part of these tricky moments. So it can be directly in the BigQuery or LLM in the pipeline, it's how you want. So we're going to next part. It's my favorite part because it's data pipelines. We talked about ML pipelines, now it's data pipelines. So after we have our probabilities. So we need to use them. We need to share our suggestions with the business units, with our consumers. So we transform ML pipeline results for Opus and for business units. What we are doing, we define and apply thresholds in our data pipelines. We convert the formats for Opus. We enrich the data with the details because, of course, just the probability and the concept ID, it's not enough for business users. We are calculating dimensions and metrics for the analysis, and we check the data quality. Here it's we are using DBT pipeline and elementary. It's very sad they are not paying me for this, but I really recommend you to check if you're a data analyst or data engineer these tools, because it's an easy data engineer tools to create the data pipelines. So thank you for the owners of this. Okay, and at the end we have the multi-BU, multi-environment transformed data for our business units LM and for Bricaman and Obramat. Here is a part of our schema of the data pipeline. And at the end, we have a qualitative, enriched, and lined scheduled data with no manual work. And with elementary, we have a Slack alerting if our data pipelines have some problems or some anomalies, freshness issues, etc. And for monitor, I don't want to focus a lot on this. We just have a Looker project with our pipeline, our dashboards to share with the business unit who doesn't have an access for Opus to check the information, with a little bit of analysis, which concepts are most problematic according to the number of outliers, so they can monitor and make some actions on this. So, I will show you the schema before and after outlier detection with this approach. So, as you remember, as it was, so I will show you the steps of our technical part. The first one is an ML pipeline, as Neil also shared ML Ops framework for the ML pipeline. So retrieve the data for the ML pipeline and create a deployment with Vertex-AI on the Google Cloud with the perfect orchestration for this pipeline. Then, of course, we store our model data in the BigQuery. Then we retrieve the data for the DBT pipeline from the BigQuery and run this pipeline deployment with the GitHub Actions for the multi-BU environment. We have the perfect deployment on this part and also perfect orchestration after. And as a schedule, we have an elementary test with a Slack alerting for the data pipeline problems. We store the multi-BU results for Opus in Google BigQuery and multi-BU results for DataVis, because we are preparing the whole data for our dashboarding before the dashboarding with all calculations. And we retrieve this data for our DataVis part. So the schema now looks approximately like this, I hope. Next step, okay, we created our suggestions, we applied threshold. Next, we need to change something in the knowledge graph. So we have the validation part on the Opus side. So we have Opus, we have the special part of the Opus, especially for the knowledge graph. We go to some concept. We go to the blacklisted product we have inside, and here now we have the human verification, the next step, the last step of this process. If it's yes or no, according to the business specialist, they verified and approved or disapproved our suggestions. But with this process, we automated as maximum all steps before just verification for the humans. And this is our improvement, in this case, outlier detection for the knowledge graph. But it's continuous improvement because it's only one little piece of this product. And here is just small examples of what we did, doing, or will do on this topic. And I want to show you, as a result, what is the correct content for the customer. So, imagine you are going to Leroy Merlin site, it's Leroy Merlin, France, and want to search some barbecue products. You create a search query. As a result, you have results without the blacklisted products. It's like the shadow result for the customer. The customer is just happy because it's what he or she wanted, but it was a huge work behind. So we have a customer, there's good queries and good recommendations, and thanks Leroy Merlin, they will return next time. Thank you. I think that's all. It's my LinkedIn if you want.
So thank you all for participation. I hope that the talks were interesting for you. I have been working in Adeo, so I can add regarding the knowledge graph. There are different strategies how you create the platform. And one of the strategies is to use the knowledge that you already have in the company. If you take the Leroy Merlin or Adeo, they have a huge experience. What is the best complementary products for a barbecue or for n'importe quoi. So, yeah, and that's why if you follow this strategy, you will create the population rules, you will validate that, and you will create the configuration to be sure that the quality of your data and the links between will satisfy the customer. So, and then, of course, you need this stuff detect this little percentage of outliers, to improve the experience one more. One more time, thanks everyone. Just a small promotion. 28th March, there will be a conference, Data Days in Lille. We are sponsor of them. So yes, it's a conference from the creators of DevFest Lille. So we will be there if you want to speak with us, but nevertheless, so come and speak, take a... That's, yes, yeah. So thanks once again. And there are the beer, the soft drinks, and something to eat. And of course, you can speak with the speakers in French or in English. Thank you. Bye-bye.